Hi everyone. Now we'll be talking about the system design of a map application. Most of you must be using Google Maps, but there's also Apple Maps and a lot of applications like Uber, Swiggy, Zomato. They use map applications or their own versions of map applications to build estimated times of arrival and also provide the best possible routes from a position A to a position B. So if you have a source and a destination, the primary responsibility of this application is to track where you are right now. When you're starting from a source, you want to go to destination. Whatever route you choose, we will be able to track your location and provide you the best updates right now. The second thing is, initially moving from source to destination, we want a route. And also while we continue on our route, we want our route updated. So a route from source to destination. At any point, if you want to add a location in this map, let's say you want to add a restaurant or you want to add your own house maybe, Google Maps will provide you a feature by which you can add locations. Uber needs to add locations again. Sometimes it takes it from Google Maps. I mean, assuming that it goes and buys data from Google Maps. And if there is a restaurant application, then what you need to do is whenever a restaurant is being onboarded onto your application, you need to know exactly where it stays. So that is adding new locations, finding nearby stores. This is not just stores. An example of this would be finding nearby restaurants, pharmacies, gyms, and so on. Okay. So finding something nearby after having specified what you are looking for, whether a restaurant or a gym or whatever, is a feature that some map applications provide. This is not relevant for Uber. This is also not relevant for Swiggy, but it is relevant for Google Maps if you are asking for a gas station nearby. We'll keep it limited to only finding the gas stations nearby, meaning in a 1 kilometer or 2 kilometer radius. I will not be looking at the gas stations which are on your route and should come within 10 minutes. Okay, that's also another type of search which you can run in a nearby search. But to keep our application simple, we are just going to be looking at everything nearby in terms of a Cartesian distance, not in terms of you're going from a position A to a position B, and there can be a gas station over here, C, but 1 kilometer radius is over here. Okay, this is not what we are looking at. This is what we are looking at. You're at A, tell me all the nearby gas stations. This makes the problem simpler. If you want this, then what needs to happen is some sort of a more advanced algorithm which can give you a full shape in which you can search. Okay, it's possible. Of course, it's possible. But searching in a polygon is, as you can expect, a little harder. Traffic updates is something that we need in Google Maps. It's essential for a person moving from a source to a destination to know whether there has been some sort of a road that has, been broken down, or there is extreme amount of traffic, or a car has broken down in between. Whatever be the case, the traffic will therefore update, and you need to have a notification for that traffic update. Estimated time of arrival seems to be a function of routing from source to destination. However, estimated time of arrival is important because you can tell exactly when you reach a place, or how long will a particular route take. If you take, let's say, the right instead of the left, how much longer will it take? So it's a critical feature of the map application, and whether you build it into the algorithm or not is up to us. Most likely we'll build it into the algorithm of routing. Apart from these, there are a few features which I mentioned in red. These are things that we'll not be picking up. And the first one is public transport. Public transport, you might think of it as similar to moving from a source to a destination, but public transport has certain nuances. One of the things is it is regular. So every 3 minutes you have a train going from one place to another. The second thing is public transport has a start and end time. So the first train starts at a particular time, the last train ends at a particular time. There's cost involved. There are routes in the public transport that are involved. So you have to store trains, you have to store, in case some train is broken down, you have to store that also. It is in fact a little easier to do than doing a simple route from S to D, because the number of routes are limited here. But it's not something that we'll be looking at. You can pick this up as a home assignment and come back to us. I'll be adding some relevant links in the description which optimize for public transport. Time to leave. So if you have a custom time to leave, let's say you are thinking about reaching office tomorrow on time, and so searching for the route right now is not very relevant. When there's peak traffic, you never know what route you should choose. So changing the time to leave is not a complex operation, but we'll not be looking at it right now. If you want some sort of idea on how to add a time to leave here, think about historical average times to move from a position A to B. okay, and then break it down recursively. Maybe you have a historical position moving from here to here and so on. So you choose the route based on the amount of traffic for that time, but I'll leave it at that. Ratings and reviews, it's critical for a lot of businesses who are using map applications like Apple Maps or Google Maps to have a high rating and to get good reviews here. So it's a very important business requirement, but it's not a core feature of the map for us who are giving a system design interview or are thinking in terms of how do these map applications work. So we are keeping it aside. Live sharing, again, this is more to do with temporary sharing of your location with another person. What kind of permissions do they have? Can they see you continuously? How do you, let's say, share your location with 10 or 15 people at the same time? Do you broadcast it? Do you keep it in one place and everybody else pulls it? These considerations we'll be not looking into at the moment. They'll be a little more clear, let's say, when we go for web conferencing application. Okay, Zoom call, for example. Now comes location history. Location history is actually extremely simple to store. We might end up solving this problem, but we are not going to tackle the problem beforehand. We are not going to say that location history is very important to us. This is useful if you want to see in the last year what are the places you visited, or if you want to share the locations that you visited with some family member or something. It's a feature that is provided by Google Maps. It's not very relevant in our case. It's probably going to be already covered by just taking care of these things, because location tracking is there. Just storing the history should do the job for you. Right, so let's look at the core problem again. You move from a source to a destination. Give me a route. Okay, even before location tracking, let's just pick the easiest thing. The best route, of course, will be a straight line, but most of the times this does not exist. So this would minimize distance, but what we really care about in any kind of application is to minimize time. So if you can minimize time, then you can go ahead and try to minimize distance also. If two routes give you the same amount of time to cover, maybe you want to minimize distance, or you want to minimize travel difficulty. One of the things which will come up here is turning. So if you're going on a highway, you head 30 minutes straight, or you can go on a really thin road, you head 30 minutes straight. You'll probably prefer the highway. You're okay taking a minute off also just to reach the highway. The reason being that traveling is much easier and the probability of the highway crashing is also lesser. Crashing in the sense that a probability of the highway having a problem. This also brings the problem that you want to minimize chance of route changes. So maybe that's another factor to consider. In our case, to keep things simple, we'll focus on just one thing, and that is minimizing the time. You can minimize tolls, chance of route changes, travel turns, distance. It's a multi-factor function, or multiple parameters have to be optimized and you can give them different weights. But for us, you're basically minimizing time.